Hi everyone. Thank you, Daniel, for your warm presentation. I want to join you, and I want to thank Iñaki for all the job he has done and what he has doing. In fact, he's one of the main authors of JsSIP along with me. First of all, I was just curious. I would like to ask you, how many of you are you or have you already built any WebRTC application using JsSIP? Or how many of you are you using any WebRTC? Okay. Okay, nice to see that much people. Okay, a bit of history. Well, we start building JsSIP as soon as we realized that WebSocket was coming in standard. And we, of course, started by zero, writing it from JavaScript. Of course, it uses WebSocket as a transport protocol, which later came to an RFC. JsSIP was when the client side used for the draft, who became later an RFC, along with OverZip, which is and also a state-of-the-art WebSocket outbound proxy made by Iñaki Baz. Of course, we use it uses WebRTC on the media plane, and as you may know, it's quite widely used in open as well as private WebRTC applications over there. Of course, the main target of JsSIP in those days was bringing SIP to web browsers, which was a new landscape that thanks to WebSockets, SIP users could enjoy. How do we interact with WebRTC? We use the browser RTC engine in order to get the media devices, and use later the RTCP connection to get the SDP and make all the media stuff, STAN, ICE, DTLS, SRTP. As you may know, different web browser vendors have the WebRTC API using their own prefixes, and for that we use RTC Ninja, which is a JavaScript shade or wrapper around the web browser WebRTC API made by eFace2Face, where Iñaki is working. So we use this skin, WebRTC API skin, to manage the browser WebRTC API. Well, as I have just said, what RTC Ninja gave us is an API, a common API for the different browsers, and allows us abstracts from the differences of the different vendors. So we could get the user media by accessing RTC Ninja, get user media, and we will do it the same way in all the browsers, and not only the browsers, as I'm going to say later. Where can we use JsSIP? We can use it in the desktop, natively in the browsers, Chrome, Firefox, Opera. We can also use the Themasis plugin in Safari, Internet Explorer. Internet Explorer, I have to say that I haven't tested. And in Android, we can also use it in Chrome, Firefox, and Opera browsers. And it's not that much time that we can use it in JavaScript applications, using the native web view in newer Android versions, newer than 4.4, which the web view it's based on the Chromium project itself. And if our Android version is smaller than 4.4, we will have to use a cross view with Cordova, so we can create our JavaScript applications. And recently, eFace2Face has also created an open sourced plugin for creating JavaScript applications with iOS, which is called the Cordova plugin iOS RTC, and I forgot to create the link, I think. Yes, I'm sorry. So if you want to get the Cordova iOS RTC plugin, it's in GitHub face-to-face repositories. So they have, for this iOS plugin, they have built a wrapper by using Swift and the native iOS SDK. So you can just use the typical JavaScript API for WebRTC as if you were using a browser. And what is more, you can add this plugin as the RTC Ninja engine, which means that you can use RTC Ninja with JsSIP independently, whether you are in a desktop, in a mobile, or in Android or iOS. So from here, I will thank again Iñaki and the face-to-face team for creating and open sourcing this stuff. I will just go quite fast through the JsSIP API. I have to say that it's, of course, event-driven. We will have events for successful and failed WebSocket connections, registrations. We will have events for a new call, for a new message, even if it is incoming call or outgoing call. And for every call, we will also have some other events, answer, fail, terminated. So we can base our applications on defining the corresponding callbacks to these events. The methods are also intuitive and very easy to use, which, as you can see, you can start, stop, register, unregister, call. You can terminate a call, hold, mute, send it TMF. So I can't find any way that it could be easier. Configuration-wise, there's quite wide configurability, not that much. I will say there are like no more than 20 configuration parameters. We don't find there is a need to have more parameters, and there are only two mandatory parameters, which are the WebSocket server and SIP URI. You don't even have to set any password. With these two parameters, you can create a user agent and start using JsSIP. And for further information, please, you can check the documentation. Okay, let's go for some examples. Of course, first of all, if we are using a browser, we are downloading the library this way. You can take it from the server, or you can have it yourself in your servers. And this, can you see it? In just 3-4 lines, you can have a user agent, just defining the WebSocket servers where we are connecting and the SIP URI. So this is an example. If we want to register, to have merely a user agent that just registers, this would be enough. By default, there's a register configuration parameter that will register automatically. So whenever the WebSocket connection is made, it will send a register, and then periodically, by a default timer, which can be configured, it will register again and again. So with this few lines of code, we will have a user agent which registers with this user against this WebSocket server. If we want to manage, or if you want, we want to manage, have more control over this, we can configure the event callbacks. So we've got here the registered callback and registered callback, registration filed callback. Here we just send some messages to the browser console, and then we just tell the user agent to register. That's all. In order to send a SIP message, it's quite similar. The event callbacks are always, of course, optional. So we just could set the target, the content of the message, the optional event handlers. We will have a callback executed every time when the message has succeeded or failed based on the SIP answer or based on the transport error. And for outgoing and incoming messages, we can set a callback, which is a new message. There we can check whether the message is an outgoing one or it's an incoming message. We can check, of course, the receiver content, inspect the headers, the SIP headers, and then accept it, which is done by default. This is not even needed. Or we can reject it with a custom response and reason phrase. Same for call. It's just the same. Instead of send message, we just make a call. We here just indicate event handlers, but we could say that we want to make video call, audio call with this, use these ICE servers, STUN servers, or wherever, and same for the callbacks. So once we have seen this fast overview of the API, we are going to check how to build an application. And there's I'm just speaking about the client, but there's an obvious question, which is, okay, what about the server? How much of server logic do I need? So this depends on your application. If we want to build a service or an application where all the users are RTC web users, and we just want to communicate them, we need outbound WebSocket SIP proxy, for which Kamailio is perfect, and a SIP registrar. We could, of course, use Kamailio as well. If we need to have a gateway because some of the peers are not WebRTC, then we will need a gateway, a back-to-back user agent supporting WebRTC, and same for media management. If we need recording, conferencing, or some kind of media handling, we will also need a media server which support WebRTC. Here I will show briefly two examples. One of them I briefly presented on Tuesday, and it's a typical, well, the typical HTML button to make WebRTC calls or receive calls, and then a WebRTC audio conference application, which will need some of the server side. We will need some more infrastructure. Okay. For the bottom, one of the things I really find crucial that are really important are that we need to give the web developers an API as less job as we can. We have to leverage to them how much do they need to know about SIP, and just let them make funny and wonderful web applications, which is something that SIP people don't used to really know, and so each of us can concentrate on where we are the best. So the aim is having these lines of code where a user can just create a button and download the library, which is using, in this case, JsSIP. We could have as many buttons as we want. In this example, what we do is by using the data elements of the button, we set the configuration options. So this is the way we are setting the WebSocket servers, the URI, or whichever configuration option we want. How can we deal with the button? Well, we will create some CCS classes to draw the button, to change the color. We will have some classes. One of them will be the default class, which will represent that the WebSocket is connected and we are ready to call. This could be blue, a dialing call, could be orange, saying that the call is in progress. The answer call, change the button color to green, the error, red, wherever. As you see, we join this status with events. These are JsSIP events. So when call is failed or WebSocket is connected or there's a global error, we just color the button to red or to any other. So on JsSIP events, we change the CSS class, and also we bind the click method to the corresponding action. If we have just answered the call, the click method will be to terminate the call. Since we've got an only button, we don't have the possibility to put on hold or mute unless we create another button. So how can we do it? Seeing it in code. For this, we are using jQuery. You can avoid using jQuery, but well, what we have done is just add the jQuery to this library, and we use it internally, so it doesn't affect the web page at all. We can use it. We can use the jQuery version we wish. So when the WebSocket is connected, we take all the buttons in the web page and we set them to ready. We add them the default CSS class, which makes them look blue, ready to call, or yes, blue, ready to call. And we bind the call function to the click event. When there's a call ongoing, let me check. Call generation callback. Sorry. Okay, sorry. So when the call has been answered or is in progress, we will make the button change the color to orange, for example. We will set dialing, calling, progress text in the bottom, and we will bind the click method to terminate this call. So it's that easy. So we see that it's boring. I'm sorry for that. We are going to do a fast demo with this button, so we see it in action. And so we can find it here, for example. We go to the click to dial section. This is a place where you can configure the aspect of the button. You can change the size of the button. You will see that when changing this is the example, the button example that is affected by these changes. I will set it as small, medium, of course. You can call the text of the call, you can change whatever. And then, this is also being generated on the fly. These are the 2 lines that you should copy and paste in your website. This one is a demo button, as you can see. I know that we are connected to the WebSocket servers because the button is blue. Otherwise, it would be red, and there would be a message in the button explaining the problem. Let's see if there's sound. The other day we couldn't hear anything. So there's some, I don't know why, but every time I connect.
I know why. Go to your preferences of your Mac.
Okay.
Sound.
Okay, sorry.
Go on output.
Output, yeah. HTML.
Output.
Okay.
And then make it louder.
Thank you.
Be careful, Jose, he'll have the gaffer tape out next.
Yeah, for sure.
Okay. Okay, so let's give access. So this is just, this is coming from a standard SIP and RTP server, which is the IPTEL server, just we choose it. And this is the click to. I don't know if you can see how the color changes, for example. It's just that easy. There's an only button, so you can just call and terminate. That's all. In many cases, this is all what we want. So this was one of the examples. And now we are going to any question about up to here? Or, okay. Now let's go to a WebRTC conference application. This is a WebRTC audio conference application. We are using the SEMS web conference module which will mix the audio. As a WebRTC server, we will use the Frapos WebRTC gateway, JsSIP, and the key piece, Meteor.js. What do we have with the Meteor.js? Do we have a template-based interface, which is reactive, meaning that the HTML will change on JavaScript variable modifications. As soon as variable is changed, there's a reaction which makes the HTML change. So we can see, in this example, we will see how if we've got many conference participants, we will see the state of them, and as soon as they change their state, we will see because these templates are also changing in a reactive way. The data change is made within the client side of Meteor and server side, and this information is exchanged via WebSocket, secure WebSocket in this case, and messages are sent as plain as possible in JSON messages. I think you won't be able to see this. Daniel has got the slides, so you can check them later if you want. This is just an example, as we will see a few slides later how the participants are seen in the website. And this is how every participant is represented, with a join button, mute button, volumeter, and call action, for example. The call action will say what the state of the participant and what to do next, terminate the call or join the conference, and these are just the buttons. Just with this template is enough to draw 1, 2, 3, or whichever, as many participants as are in the conference. In the server side, we've got a node, Meteor.js server listening. It's communicating with the SEMS conference module via XML RPC. It's communicating with the Meteor clients via WebSocket Secure. It receives the change of the clients, which is in the end the JsSIP user agent and JsSIP call state change is sent from the participants to the server, and the server broadcasts to the other participants. And on the other hand, this server also pulls SEMS for participants' volume information and broadcasts it to all the participants. We're going to do a fast demo of this. So we'll go to the conference. Okay, we will create a new conference on the fly. I will invite my colleague. Okay, I will invite myself because this is the view of the organizer, and I want you to see also the participant view. Okay. Okay. So you should have received. I received a button here, which is just a link to the conference. Okay, organizer, Stefan is disconnected. Okay, sorry. I will bring this here. Hello.
Hi there.
Where are you, Stefan?
So that's from the back of the room.
Raise your hand. Hi. How are you doing?
I'm here on Ethics Collect. So
Yes.
I some sound quality.
Yes. I'm sorry, we're using the built-in speakers. So, and this will be the participants' view. Everyone see each other. Can you mute? Well, I will mute you. I will mute. No, please. Can you mute yourself? Stefan? Ah, sorry. And so he's muting. This mute status is sending through WebSocket to the from Stefan web browser to the Meteor server, and the Meteor server will broadcast this information to me, which we will render here. This is done with the templates that we have seen earlier. Thank you, Stefan. Okay, so, well, we could have organized the meeting, put some description in the email, set a date and a duration. And the essence of this application is the same as the click to dial one. Just being as simple as possible and letting the web developers using our API and concentrating on what we don't know how to do. It's fantastic web interfaces and simple. Okay, now to finish, I want to thank you, all of you, for your patience, and I want to send you a message saying thank you. Thanks. Thank you.
So yes, JsSIP helping a lot. I even was able to do a basic, even video client for a web page, openrcs.com, which we use for as a testbed for Kamailio development. Couple of people quite active there, more registered, but it's good that we could test also WebRTC in with the latest version that's going to be stable. Questions, quick. Here, one. Meanwhile, Stefan was already called to go and speak.
Hey. Very good. What do you answer to those who say that SIP is too heavy for the browser, that in the browser you should have just JSON signaling?
I think it's as lighter as JSON. I mean, you won't create a server running in a browser. For a user running, I'm just speaking about SIP, not about media. For a user running 20, 30 signaling sessions with JsSIP in a browser, there's no problem at all. Another thing is that you want to create 20 media sessions. That's more heavy because of the media part. Typically, well, I don't know any single person that will make many media sessions, but as far as I know, you can make, speaking about media, which I'm sorry is not your question, you could have 4 or 5 media sessions depending on the browser and your machine. But if we are just speaking about SIP, you don't have to worry about it. You can have as many sessions as you want. There's no limitation.
Okay, last question, if any. I don't know if you found it easy to integrate with the media engine from the browser. Was there any pain with that, or that simplified a lot and practically JSSIP takes care of these little bits which are the SIP packets?
Could you please, Sanil, repeat?
It was like getting access to the media server and to the media engine on the browser. Mm-hmm. Was it something complex to wrap it into a SIP library?
No, it was really easy. This is done defining the W3C specification, which is where JavaScript APIs are defined, and it's just made as a JavaScript API, so it's damn easy to integrate.
Okay, thank you, Jose. Thank you for
Thank you to you.
writing this library. As you could see, many are using it.